So for this example, we continue determining our greatest common divisor, except as we can see in here, our numbers are starting to get larger. And as our numbers become larger, the potential for factors can really grow. Depending upon the number, or depending upon how large it is, they could have dozens of factors. So to try and list them all, it can get a little overwhelming. So we're going to use prime factorization to be able to help determine what the greatest common divisor is. So for A here, for 400, we'll just do prime factorization for 400. Again, I like to start with the smallest prime. You don't necessarily have to. I just think it's good practice. That's a particular way that I like to do it. And besides, 400 is even, so right away I can see that 2 goes into it. So this is 2 times 200, 2 times 100, 2 times 50, 2 times 25, and then of course 5 times 5. So we have 1, 2, 3, 4, so I'm going to write this as 2 to the 4th times 5 squared. We'll do the same for 632. That's 2 times 316. 2 times 158. 2 times 79. And 79 is prime, so I think we got them all. So we're going to write this as 2 to the 3rd times 79. So then to determine the greatest common divisor is we have a base here of 2 that's in common between the two, and at most there's 3 in each one of our divisors here. Don't forget 2 to the 4th is 2 to the 3rd times 2. So 2 to the 3rd appears at most in both of these, and 2 to the 3rd is 8. So the greatest common divisor between 400 and 632 is 8. Let's try B. Now, of course, we have negative 272. Again, negative 272 is the same as negative 1 times 272. So all we really have to do is find the factors for the positive results, and that's what we'll do. So we have 272. That's 2 times 136. 2 times 68, 2 times 34, and 2 times 17. 1, 2, 3, 4, so this is 2 to the 4th times 17. We'll do 825. That's 3 times 275. And again, don't forget that you may see 5 and want to start with 5, which is fine, but I see 3. Don't forget, if we add up these digits, 8 plus 2, that's 10, plus 5, that's 15. 15 is divisible by 3, therefore 825 is divisible by 3. So I'm going to start with 3. And then this will be 5 times 55. And this is 5 times 11. So then we have 3 times 5 squared times 11. Now they have no base in common here. Now don't forget, we're looking for all the divisors. Don't forget 1 is also a divisor. So then 1 would have to be the common divisor, the greatest common divisor, between negative 272 and 825. So that's 1. Let's try C. We have 726. That's 2 times 363. 3 times 121. And then 11 times 11. That's 2 times 3 times 11 squared. For 1,683, that's 3 times 561, 3 times 187, and then 11 times 17. So this is 3 squared times 11 times 17. So we can see that they share a base of 3 and they share a base of 11. At most, there's at least 1 3 in both of these, so that's going to be 3. And then there's an 11, and at most there's 1 11. So 3 times 11, that's 33. So the greatest common divisor between 726 and 1,683 is 33.